Hi class. So today we're trying to build a classification model that we discussed last week. I'm trying to record a session so that I can just go back and uh, reference this analysis so that you can do the assignment on your own. Okay. Uh, so what are we trying to do here, right? You have to understand the data set first. If you can get this data set in week 6 in the course. Okay. So if you look at the data here, you have three different inputs, right? Like gender, age, and salary. Okay, you have three different inputs. You have one output which is categorical. Your output is basically either a 0 or a 1. Okay, you have nothing else, right? If it's either it's a 0 or a 1. Okay, and you have three inputs: gender, age, and salary, right? Uh, so if you look at the row second here, what it tells me is a male, a guy who's 19 years of age, making $19,000 a year, did not buy a certain product, okay, did not purchase this certain product, which means 0, okay, did not buy a product, right? uh, and then if you go into row 3 here, male again, 35 years of age, making $20,000 a year, did not buy this product again. Okay, so you have to understand the data set first, right? uh, if you go into row 9 here, female, 32 years of age, making 150 grand a year, brought this product, right, purchased this product. Okay, uh, so what you're trying to do is you're just trying to basically build a model where you can actually predict. Let's say these are all historical data, right, of your clients. Okay, and then let's say you're trying to predict. Let's say in the future, there's a new client who is a male, 35 years of age, making $78,000 a year. Okay, so you're trying to understand if this person will buy this product or not, if this person will purchase this product or not, right? You're trying to predict this. Okay, you're trying to predict this, right? Uh, Same again. You can run multiple scenarios, right? Female, let's say female, making who is 28 years of age, making $120,000 a year. Will this person buy this product or not? Will this person purchase this product or not? We are just trying to predict those. Okay. Uh, so for that, you'll have to build a classification model. You have to build a classification model. Whenever your output is categorical, 0, 1, true, false, male, female, whenever you're trying to categorize your data into different categories, you'll have to build a classification model. Okay, so that's very key, right? Uh, so for that, you'll have to install a toolkit. Okay, you'll have to install a toolkit. If you go into insert here, there should be get add-ins options here. Get add-ins. If you don't see it here, you'll have to go into file. Okay, and then get add-ins here. Get add-ins. Okay, uh, so get add-ins. It'll take you to this store here. It'll take you to this store here, and then just type XLMINER. XLMINER. Okay. Uh, Search. You'll see these two different tool packs. Just see XLMINER, right? Install the first one. Add. Okay. Install the first one. I agree. Continue. Okay. Uh, you should see something like this once you install the toolkit. Okay. If you don't see it, go into home and you should see something like this here. Show tool pack. Okay. If you click here again, you'll see the tool pack here, right? Some of you might have some problems while installing the tool pack. There'll be an error. So make sure that you sign out of your account and then log back in again. Okay. Make sure there's no error here in your account as well. Okay. Um, so make sure there's no error in your account. Okay. Um, Make sure it's properly signed in or just signed out as well. It doesn't matter. If you just do that, you should be able to install this. Okay. Uh, all right. So a classification model is basically a logistic regression model, right? I've talked about that in class. I won't go into detail today. So you'll have to build a logistic regression model. Okay. So click here. Your Y range is basically your output, right? Your Y range is your output. So your output is basically your purchased here. So I'll just drag all the data. You have only one output and multiple inputs, right? Uh, so click on the Y range, drag all the data for the Y. Okay. Uh, Here. So basically it's E1 to E401. Okay. E1 to E401, right? So for input range, right? Your input range is basically gender, age, and salary. Okay, gender, age, and salary. But the problem with gender is it's qualitative, right? It's not quantitative. Okay, it's not quantitative, right? Uh, so whenever you have qualitative data, whenever you have all these non-numerical data, make sure you change it into numerical as much as possible, because you can only feed numbers into the model. Okay, you can only feed numbers into the model, right? So I want to quantify my input. Okay, I want to quantify my input. Maybe for now, just leave this. Just make this empty. Let's quantify the inputs for now. Okay, so gender. I want to quantify my input as much as possible. Age is already quantified. Age is already numerical. Salary is already numerical as well. So no need to do anything there. For gender, let's quantify this, right? So what I'll do is I'll just write a function that tells me, okay, give me a value of 1 if it's a male, give me a value of 0 if it's a female, right? Um, so basic function equals to if this value equals to male, comma, give me 1, if not, give me 0. Okay, so if this value equals to male, give me 1, if not 0. Okay. Um, so what happens is, if this is a male, it'll just give you 1, right? If it's a female, it'll just give you 0. Okay, you can do the other way around as well. If it's a female, give me 1. If it's a male, give me 0, or 1, 2, 2, 3, doesn't matter. Okay. uh, all right, so you've quantified your inputs. Now let's go back into logistic regression. Okay, uh, your y is basically your purchased again, right? I'll just drag everything uh, here. Okay, so F1 to F401, F1 to all the way from 1 to 401. Okay, you can just type there as well. You don't have to drag it, right? Your X range is basically now your gender, quantified, age, and salary. Okay, so you have 3 of these, right? You've quantified your gender, your age is already numerical, your salary is already numerical as well. Okay, so these 3, right? All right, and then in the output range, just click here and click anywhere in the empty cell here, anywhere, doesn't matter, maybe here. Okay, J6, just click OK. All right, so I'm just trying to open a PPT here, PowerPoint from week 6. Just give me a sec here. All right, so if you go into week 6, there's a doc presentation PowerPoint there, and if you go into slide 14, we talked about this classification model, right? So I'll just talk about this slide 11 here, which basically gives me the function. Okay, so this is the function that we're trying to build here. P equals to 1 divided by 1 plus e power minus beta naught plus b1x. Okay, so this is the function we're trying to build. But basically, this is nothing but, so if you look here, so we talked about this, right, last week. This is the linear model, isn't it? Y equals to mx plus c, right? Uh, and then if you think about p, so p is nothing else but p equals to 1 divided by 1 plus, okay, e to the power minus, this is your linear model, isn't it? Y equals to beta naught plus b1x, beta naught plus b1x. So 1 plus 1 divided by e to the power minus y. Okay, you're trying to, let's build a linear model first, and then we'll go into building the logistic model, right? So we're trying to do that. Okay, so I'll just copy this into, I'll just copy this graph here, right? So let's build this linear model first, right? Linear model first. You know how to build a linear model. We've done this in the regression as well. If you look at the summary output here, you have the intercept, which is C. You have x1, m1, x2, M2, X3, and M3, isn't it? So this is M1, X1, M2, X2, M3, X3. This is your C, right? So you can build a linear model from there, right? And then once you build that, we can build a logistic model, okay? Uh, but before building the linear model, what you have to do is you'll have to look at the p-values, isn't it? You'll have to look at the p-values here. So if you look at the p-values here in this summary output, so if you look at the p-values here in the summary output table, so the p-value for gender is more than 0.05, isn't it? The p-value for gender is more than 0.05. So you cannot have gender in your model, okay? We talked about this, right? You cannot have gender in the model. So since the p-value of gender is greater than 0.05, the input cannot be included in the model. Okay, so we've talked about this, right, in our linear regression work as well. Okay, so what you'll have to do is you'll have to go back into the data set and rerun the regression again. Rerun the regression again without gender, right? Okay, so go back here, do the same stuff here. So tool pack, logistic regression. Okay, your Y range is the same, purchased here. Okay, purchased F1 to F401. Your inputs are now just age and salary. Okay, age and salary only, right? Your gender doesn't play a factor in determining your output. Okay, so it's not significant because the p-value is more than 0.05, right? Okay, so only D and E, right? D and E only. So age and salary is your input. Okay, so your output range is, again, I'll just click here, paste it somewhere here, G24. Okay, right? Move this graph here. So you have a new summary output. You have your new summary output, right? So summary output 2 here. Okay. So just quickly look at the p-values, right, before building the function. Here looks good, right? Because this is E minus 19, which means you have 19 zeros in front of you, right? Basically, if you just click this comma style, it's a 0. If it's a comma style, it's a 0 again. Okay. So p-values are less than 0.05, right? So these two factors play a role in determining your output. Okay. Determining your output, right? So let's build a function. Right? So your linear model is basically nothing but your output, which is your purchased. So y equals to m1 x1. You have two inputs now, m2 x2 plus c, right? Y equals to m1 x1 plus m2 x2 plus c, which means purchased equals to m1 is this value here, 0.233 times age, okay, plus estimated salary is this value here. You can just click on the value and just grab the value from here, right? Plus this value times estimated salary plus your intercept, which is basically plus times minus 12.433 is minus 12.433. Okay. So this is your linear model, right? This is your linear model. Okay. So purchase equals to 0.233 times age plus this value times your salary plus the intercept, right? M1, X1, M2, X2 plus C. Okay. Right. So the next step is basically you just bring this linear model into you build a linear model, right? So the next step is to build a logistic model, because you have the linear model now. So a logistic model is nothing but p equals to 1 divided by, if you look at this function, 1 divided by 1 plus, right? E is basically exponential, okay? Exponential minus your linear function, okay? So we're trying to build this. Right? P equals to 1 divided by 1 plus exponential minus. All right, so we build the linear model. The next step is to build the logistic model, right? This function here, okay? So basically, which is P equals to 1 divided by 1 plus exp exponential power exponential minus your linear function here, okay? This y here, okay? So for that, you'll have to just go back. I'll just copy this function here, linear function, copy this, move it somewhere here, okay? So start building the linear function in your all the inputs that you have, okay? So let's say linear function, okay? Linear function. So basically, it's nothing but equals to 0.233 times your ease here, right? Ease, okay, plus 0.00000359 times your salary here, okay, and then minus 12.433, okay. So this is your linear function for each of the inputs, right? So just double click here. Next is logistic function, okay. So logistic function. So again, I'll just drag this somewhere here. So logistic function nothing but equals to 1 divided by, just look at here, right? 1 divided by 1 plus e is basically exponential exp, okay. Bracket open, you have minus in front of your linear function, minus your linear function here, okay. Close again. So 1 divided by 1 plus exponential minus your linear function, okay. I'll share the sheet as well to you guys. You can look at the formulas by yourself as well, okay. All right. So you have the logistic function. So what you've done here is basically you've just calculated the probability of this event happening. You just calculated the probability of this event happening, right? These are all the probability. Okay. Uh, so in a classification model, what happens is if the probability is greater or equals to 0.5, you'll have to assign it as a 1. You'll have to assign it into a category, okay? So what you're trying to do is you're trying to categorize the data into different buckets, right? In different categories, okay? Um, so basically, your prediction is you're trying to categorize whichever observation that had probability of greater than 0.05, sorry, into one probability. If there's a probability that is less than 0.5, assign it into a 0 bucket, okay? So a basic formula again, equals to if this value is greater equals to 0.5, assign it into one category, okay, purchased category, okay. If not, assign it into a 0, not purchased category, okay. Right? So this was your prediction. Okay, so you build a linear model, you build a logistic function to all the inputs. This is the prediction that you got from the function, right? So what you're saying is, okay, for this observation here, the actual was 0 based on your function. Your prediction was 0 as well. Okay. Same here. The actual was 0, prediction was 0, which is good. Your model is working now, right? Here, the actual was 1, your prediction was 1, which is good. The model is working as well. Your function is working, okay? But if you look here, the actual was 1, okay? This person bought the product or purchased the product, but based on your function, the prediction is that this person won't buy this product, right? So with any model, you'll always have inaccuracies, right? You're trying to maximize the accuracy in your model, okay. So for that, it is very essential to understand like how accurate is your model, right? How accurate is your model? Okay, so that's why we went through the whole this exercise before we starting to predict. We need to understand the accuracy of the model. Okay, um, so what we're trying to do is we're trying to do understand, okay, prediction versus actual, right? Like in how many instances the prediction was actually the same to the actual, right? We're trying to understand that. Okay, so this is your actual here. This is your actual. Uh, so prediction versus actual is basically equals to, is this value equals to this value? I'm just trying to understand that. Is it a true or a false? Okay, is it a true or a false? Um, So in this instance, it's a true because it's a zero here as well, one here as well. But if you go into false here, it's a one here, zero here, one here, zero here as well, right? So your model has failed in these false instances, in these false observations. But in the true observation, it has worked perfectly, right? Uh, so in order to understand how good your model was, you just count the number of truths in the model to the total observations, right? You're trying to understand the model accuracy now. So model accuracy is basically you'll have to count the true, you'll have to count the false, you'll have to count the total observations, which is nothing but true plus false, right? And your model accuracy is nothing but the ratio of true divided by total. Okay. Uh, so I'll count the number of truths, right? I'll count the number of truths in this range here. So again, Excel formula equals to count if. You can do it whatever way it's easier for you. Okay, so count if. It'll ask for the range here. My range is this. I'm just trying to count the truths in this range here. Okay, I'm just trying to count the truths in this range here, right? So I'll grab all of these. I'll grab all of these. Uh, so this is your range, right? J2 to J401. And then comma, I'm trying to understand the true. How many true do I have? Okay, so I'll lock the sales as well. So ampersand, ampersand, basically the dollar sign. Okay, ampersand, ampersand before your row and column, right? So you have 337 truths overall. Okay, so I'll copy the same formula again in the false, and I'll change this true to false to count the false. So that's why it's very essential to log the cells, log the cells. Okay, 63, right? The total is basically true plus false. This plus L8 400. Your model accuracy is basically the ratio of true to your total L9. Okay. So this is your accuracy, right? Like you are able to find, okay, like your accuracy is 84.3%. Your model is 84.3% accurate, which means 8 out of 10 observations you are able to correctly predict, right? So your model is pretty good. The model is pretty good, right? So now you have an understanding of how good your model is. Okay, if your model was only 20% accurate, there's no point in doing prediction, right? There's no point in doing prediction. Okay, uh, so you'll have to, now you're okay with your prediction, you're happy with the accuracy of the model. Now you can actually go and start predicting, right? Because now your model is pretty good. The model is pretty good. Your function is pretty good as well. This function that you built, uh, these function, linear function, logistic function that you built is pretty good, right? Because it's 85% accurate. Okay, so now you just go here and let's say randomly, right? If we need to predict, you can just tweak different inputs to see how it changes. Okay, so let's say I'm just trying to predict few observations, okay, in the future, right? Let's say there's a male, uh, mean male who is do not have any empty rows in between these two cells, okay, because the function won't work. So make sure there's no empty rows here. So male, let's say 30, randomly, right? 33 years of age, making, let's say, $80,000 a year. Will this person buy the product or not? You're trying to understand that. Okay. So now based on your modeling, which is 85% accurate, you're saying, okay, this person won't buy this product because your output is zero here. Okay. Uh, Same here. You can play with different numbers. Female, who is 42 years of age, making 200 grand a year, will buy this product. Okay. This is your prediction now. Again, female who is 28 years of age, making $100,000 a year, won't buy this product. So this is your prediction. Okay, this is your prediction. So this is what we're trying to build, right? You can play with different inputs and see how your output changes as well. Okay, so this is the classification model. Again, whenever you have to predict a categorical output, either if it's a 0 or a 1, either if it's a true or false, male or female, you're just trying to categorize the data into different buckets, right? You'll have to use a classification model. You'll have to calculate the linear function first. You'll have to calculate the logistic function, which is basically a probability. And then you'll have to assign those probability into different buckets, right? And then basically by this cutoff score of 0.5, and then you assess the prediction versus actual to find the model accuracy. Once you're happy with the accuracy of the model, you go and start predicting stuff. Okay, awesome. So please use this as a reference and then just work on your assignment, which is pretty it's not a huge data set. It's only uh, 15 rows of data, I guess. Awesome. Thank you so much.